Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. This is video number 11 in our video series regarding the ethical use of AI in research. In today's video, we're going to see how we can test the normality of our data. So normally, the type of our data, whether it is normally distributed or not, determines what type of test we are supposed to use on that particular type of data. So if the data is a kind of normally distributed, so we can now use the parametric test like the t-test, the the ANOVA and the rest. While if the data are not normally distributed, then we can now use the non-parametric test. Example of like Demand Whitney. That is instead of the t-test, that is independent two sample t-test, we can employ the Mann-Whitney, or we can use the Kruskal-Wallis instead of the ANOVA. So then definitely it is important for us to understand the data, whether it is normally distributed or not, because that will determine whether to use parametric or non-parametric test. So in today's video, we're going to utilize the SPSS to test that. And at the same time, we're going to use the AI to see whether it can be able to test the normality of our given set of data. So we're going to utilize the two. Let's assume this is this set of data. Let's say independent data. So maybe it's a score of a certain cost on different occasions, which they are somehow independent. So we want to see whether this set of data or this set of data is normally distributed or not. So if it is normally distributed, so we know that we can apply the parametric test to do the analysis. If it is not normally distributed, then we can now use the non-parametric test like the Mann-Whitney and the Kruskal-Wallis. So let us just launch the SPSS. So okay, before that opens, let me just okay, let me open ChatGPT, and maybe I can also utilize the DeepSeek. So now let me come back to my SPSS. So I'll go to the variable view. I have two different scores which are independent. So the first one is score 1, then the second is score 2. So I will change the measure to scale because they are. So I can now copy the data from this. So let me just highlight them all. Then I can now copy the data and paste it here. So in SPSS, we can check the normality in different ways. One of the simplest ways is to go to the analyze, then we come to the descriptive statistic, then the frequency. So under the frequency, you can now come to this chart. So you can choose a kind of histogram. So on it, you now select the show normal curve and histogram. So you can now click on continue. So you can now choose all these data, then you take them to the appropriate variable listing. So you can now say okay. So you can now see uh, the uh, the histogram comes with a normal distribution bell curve. So here, normally in normal distribution, we know that majority of the readings cluster around the what? Around the mean. Only few will be at the extreme edge. That is the less likely ones. But most likely will be around the mean. So if you critically look at this, so it is only here that we have some of the most likely. Here we don't have the most likely. Almost everything centered around uh, the the distance. So let us check for the score 2 also. So the score 2 is somehow more of like a normal distribution curve. As you can see under the less likely, we have some variables. Here we also have some variables. Then majority cluster around the center. But this cannot tell you whether the uh, the datas are normally distributed or not. So we have to use the other method as well. So we can come to the analyze, then descriptive. So this time around, instead of the frequency, we go to explore. So we can now choose our datas, then we take them to the dependent list. So under here, we can now come to the plot. So you make sure you uncheck the stem and leaf. So you now choose the normality plot with test. So you now continue. So you now click on what on OK. So normally it will use two uh, tests to test the normality. One of the tests is the Shapiro test, while the other one is the Kolmogorov test. So in each of this one, it will uh, give you the significant, which is the p-value. Then you now compare this value with your 0.05. If this value is less than 0.05, it shows that it's significant. So that means the data is not normally distributed. Because your null hypothesis will now be that the data is normally distributed. But here, for instance, if the value is greater than 0.05, it shows that you go with your null hypothesis. That means that the data is what is normally distributed. So under the Kolmogorov test, we can now see for the score 1, it got a value of, it presented a value of almost 0. Then under the score 2, gives a value of 0.53. So you see 0.000372 is less than 0.05. So we can now make a conclusion based on the Kolmogorov that the data in the score 1 are not normally distributed. So under that is the second score using the Kolmogorov. Then we got a value of 0.53, which is greater than 0.05. So we can now say that the data too are normally distributed. So we can now come to the Shapiro test also. So you can see under the score 1, it also got 0.0091, which is less than 0.05. So this shows that data is not normally distributed. But under here also, we got a value of 0.93, which is greater than 0.05. So here we can now say that the data is what is normally distributed. In a situation whereby you have a conflicting output from the Kolmogorov and the Shapiro, so you always go with the Shapiro because it is somehow more accurate than the Kolmogorov. So in this particular case, we have a kind of a harmony when it comes to data 1, that in all of the scenarios that it shows it is not normally distributed. Then when it comes to the data 2, it shows that it is what normally distributed. So that means if you are to analyze the data 1, that means you are to use non-parametric tests. Like if you want to use the t-test for the independent two sample. So instead of using the t-test, you can now use the man-Whitney. So maybe if you want to do a kind of an ANOVA of those data that are not normally distributed, so instead of using the ANOVA, you can use the crystal Wallis. So, but in this particular case, actually, the data is normally distributed. So we can use the normal parametric test that we do, like the t-test, the ANOVA, and the rest to analyze all this set of data. So now let us see whether the AI can help us identify a data. A data is a kind of uh, normally distributed or not. So let me just copy the first data, which we already have an output that shows that this data is not normally distributed. So let me just ask the DeepSeek. Let me start with the ChatGPT. So let me say uh, test the normality of this data. Let me say using, since we have used the Kolmogoro and Shapiro. So I will now paste the data. So I will repeat the same thing here. Let me say test the normality, let's say of the data. Let's say using Kolmogoro and Shapiro, Shapiro, Shapiro test. So I can equally paste the data. So I can now send it. So here, I think I can also search, send the data. ChatGPT is not going. I don't know why. Let me just let me close the ChatGPT and reopen it again to see whether it will respond. So I will just paste what I have just. So let's see. So let me check the DeepSeek. Okay, the DeepSeek has already done its own. So you see, it has already run the data using the Python. Then it comes to the result. It says actually it didn't give me any kind of it just show a kind of okay, let me check this, the chat gpt. Okay, the chat gpt has given us under the Shapiro, it gives the p-value of 0.099, which is less than 0.005, which is a rejection. Then under the p-value as well, under the Kolmogorov shows 0.070. So actually that was why I said initially, when you have a conflicting result, you better go with the Shapiro. So here under the Shapiro, it means the data is not normally distributed. Then here it shows that the data is normally distributed under the Kolmogorov. So let's see what the interpretation means here. The Shapiro will test has a very low p-value, indicating the data does not follow a normal distribution. Then for the Kolmogorov, it says that data might that normality might not be strongly rejected, but it is still borderline. So in all of this, since we can use the AI to have the idea, but what we obtained as our output here was under the Shapiro. For the data one, we have 0.0091, and you see for the ChatGPT also, it gives a value of 0.09. So that means it accurately captures that of the Shapiro. But when it comes to the Kolmogorov, it has a kind of an issue. Okay, let us check the second data, which we have established that it was a kind of normally distributed. So let's just copy this. We'll ask this to perform again. So maybe this time around I will not use the DeepSeek. Or maybe even if I'm to use the, let me just use the ChatGPT. Let me say test the normality of this this data using the Nomokoro and Shapiro test. So I can now paste the data. This is our second scope. Let me just close this for us to. So let's wait and see. So you see in this particular case, the second data under the Shapiro, the p-value was 0.092, which shows acceptance. Then under the Kolmogorov, the p-value is 0.395, which also shows acceptance. But one thing that you need to understand is that the ChatGPT is having difficulty in calculating the Kolmogorov accurately, because let's check the p-value of the Shapiro, which is 0.092. So from here, under the Shapiro, you see we have 0.092, which is somehow accurate. So under here we have 0.05, but it struggle to have that value. It is presenting us with 0.39, which is far higher than the other distance. So in this particular case, it is that you accept the null hypothesis, which shows that the data is normally distributed, just like the way we establish using the SPSS. But here you need to understand that you need the basic knowledge in order to do that. Like for instance, let's assume we ask the chat GPT to do only the Kolmogorov using the first approach. You see here, it is giving us a kind of an acceptance of that particular data to be normally distributed. But under normal circumstance, it should be a kind of reject the null hypothesis and go with the uh, alternative, because the Kolmogorov gives a 0.000375. So if you are to use this, I would suggest that you ask the ChatGPT to do that using the Shapiro. Or you can even ask this to do the QQ plot. It will also give you the normality of that particular given set of data. So assalamu alaikum wa rahmatullah. Thank you.